I would like to thank all that are attending our session today, the second in our seminar series for 2018. The focus is in the development of technology that will assist all woodworkers to produce faster and more accurate than ever before. Not only will the design department benefit, but we do believe the front office, marketing, as well as shop floor machining will all see benefits. Everything that we're presenting will be available on a download so that each of you will have the ability to test, try, experiment with your own particular products that you produce. My name is Steve Whittam of Whittam Associates. In our first session, we had shown how we could model this very, very quickly and also have it fully adjustable and adaptable to the needs of our clients or staff or management or whoever else needs some possible changes in the model. These were all done using iLogic, and as you can see here, if we want to change the length of this unit from 24 to 32, and we want to change the kick height from 4 inches to something else, let's say 2 inches, all we have to do is an update, and the entire cabinet changes as we requested. So the one thing about working in Inventor is that the ability to change after the fact gives us a tremendous leg up in design. Every single woodworking project I've ever seen always had some changes after we thought we were done. The other aspects of it, we take a look at some of the joinery that was built in our last session. We have some simple dados for the back. Other things are just butt together. Let's just take a look at a shelf or two on here, and we'll see what we have. So you could see that these shelves are just butt to it, and we will be showing you how they're going to be doweled or biscuit or just screwed in. The other thing about this is that these are all at one level. This is not an indented bill of material by any means. If I went ahead and looked at the bill of material, we'd have a flat bill of material showing each of the parts. The fact that it's in something called a base presentation, and each of the parts are listed with their length, width, and thickness. Okay, and this of course can go out to a Excel spreadsheet easily for cut listing. Before we go much further, what I'd like to do is group these. Obviously, when we build, we probably build the two ends independently and the interior independently, and then mull it together. So what the first thing I usually do is I'll put a window around just the area in question, or the right, it's not in question, it's the right panel, right click on it, and say I would like to take these components and demote them into an assembly, and we'll call this right unit, and pick OK. And the right unit is now in its own assembly. If you take a look over here in the browser, it says right unit, and if I want to turn the visibility on and off, you can see we now have control of that independently. Let's turn the visibility back on and do exactly the same thing with the left side. So I'm going to put a window around it, make sure I catch everything that's necessary. Right click, go to component, demote, and we're going to call it left dash unit, and pick OK. And I'll turn off the visibility of the left unit and the visibility of the right unit. So in other words, each of these will act independently and can be opened independently and used independently. I'll put a window around everything left, and I'll do again the same thing, component demote, and we'll demote this into a base square cabinet, and pick OK, and pick OK. So now if you take a look in the browser, you'll see that all of the different entities here are now independent units that could be opened up independently, saved independently, and used independently. Just pick save and save our work. Now, even though that they are now made up of 3 individual sub-assemblies, we still have the same type of control. Let's say it's 24 inches in overall, and we'll do an update, and you'll see that it's adjusting also. If we don't like the grain and grain direction at this point, let me go ahead and say I want to remove all the materials of each of the parts. That's all 23 parts. And I'll say that I should have made everything out of rift oak, and pick apply. Okay, and by doing that, it's going through the system and it's already assigning it. If I want to say that one of these pieces is going to be made out of bird's eye maple, okay, I'm just going to pick 1, 2, 3, 4, and 5 parts, and now they're all going to be bird's eye maple. Okay, so the quality of the imagery is really second to none, and I'm not even in a rendered mode. At this level here, we have an indented bill. So if we went out to the bill of material, you'll start seeing that here is the right unit with all the materials. Here's the left unit, and so on, okay? And you can also notice that if you click on this, it's going to tell you what each of the parts are made out of. So a lot of capability. The other thing is, as I said before, these are butt together. So if I move, let's say, one of these pieces, you can see they're independent. Or if we go further and we move just a shelf, you can see that the shelf itself has no joinery as of yet. And of course, that's where we're going to be focusing most of our attention this afternoon. Just a quick refresher. The tools that I'm using for material assignment are all available under Woodwork Design Assign. And in the assignment tool, we have the ability to assign solids, meaning hardwoods and softwoods, boards, which are plywood, MDF, and the like, laminated boards, and so on, veneers, edge banding, and the like. These are all tools that woodworkers definitely need, but Inventor by itself does not have the functionality built into it that we have added. Of course, this is fully customizable, and it's downloadable on the sites that I had listed previously. In woodworking construction, whether it's traditional joinery or the most modern type of furniture one builds, and whether it's wood, plastic, metal, we find that we start with simple panels a lot of the time, and we have to join them together in some fashion. And joining it could be glue, screws, could be dowels, could be biscuits, it could be knockdown fittings, it could be conformat screws, it could be really a host of different things. But we are told that we need to do something. Well, we know we have to do something. And based on the type of construction you do in the shop and what machinery you have and what kind of construction it's going to be will determine, of course, what method. The one thing about utilizing Inventor and woodworking for Inventor is that there is no limit to its capabilities. So it doesn't really matter what your construction technique is. We can let the software handle it. Again, good software is easy to use, and it's absolutely flexible. And that's what I'm hoping to show you today and how it's done. So in this particular project that we're looking at, we've got 3 cabinets now. And what I'm going to do is I'm going to turn off the right unit by turning just the visibility off, and the left unit, turn the visibility off so that we see it, a little bit clearer, nothing in our way. And if I move, say, this center panel, you can see that this is a blind dado that we had created in our first session. But as a blind dado, that's okay. But these side panels, you could see, are butt together. There's no joinery whatsoever there, okay? And you can see that there's no joinery there either. So our goal is, at least in our first step, I think what I want to do is I want to create dowel joints on all four sides. Okay, on all four sides of this panel, on this cabinet. And we should be able to do that within 30 seconds, 40. It's really quite simple because in our world, we use pretty much similar things over and over again. The size of the dowel, diameter, and length is pretty simple, pretty similar. And then, of course, the boring pattern, depending upon your boring pattern, that means what is the distance between the holes, that should be a standard also. So in the past, I've always suggested we must have standards in place that we all can adhere to. And that standard could be the standard within your company, doesn't mean the standard that is being told to you, whatever works for you. So the first thing I always try to do is to develop a standard library of items that any of my woodworkers would use. And one of those I call boring patterns. A boring pattern is for a cabinet like this, might be a 32 mil system where the first hole is a certain distance from the front and every successive hole is 32 or 64 or 96 millimeters back. Now, it doesn't have to be a 32 mil system, but that's what I'm using at the moment. So what I do here is I will show it to you first, and then I'll show you how to build one. What I'm going to do is I'm going to place what I call my boring planes. I'll pick a boring pattern. And when I create a boring pattern, it is going to be an eye part that shows you the different planes that are available to you. Now, these are just planes that have been preset at certain distances. Now, I can create a boring pattern, and if it's an eye part, I can say I want a boring pattern for things that are stretchers or nailers, and then you could see that it's only three planes. Or I could say less than 15 inches, and then you can see there's more. So that's a 15-inch depth, or even greater than 15 inches. So what's happening here is we have the ability at any time to have a preset pattern of planes exactly configured in a way that makes sense. So for example, if I measure the distance between dowel 4 and dowel 3, I'll go and I'll look at it in metric. Sorry. You can see it's 96 mil. If I go from dowel 3 to dowel 2, 96 mil. And then, of course, maybe the first grouping from here, dowel 1 to dowel 2, it's 32 mil. So again, these are your calls on what you would like it, how you would like to adjust it, how you would like to present this. Now, once we have brought in our work planes, or what I'll call my boring planes, okay, these planes can be labeled, they can be defined, and they also are preset to be a certain distance between planes, just like boring would be a certain distance between the center holes. At any point, we can change these just because it is an eye part, and we can say, no, it should have been for stretchers or nailers, and of course, it'll adjust accordingly. So one plane, or one series of planes, have the ability to really function as many. Now, we also notice that if we measure these planes, the distance between, let's say, the first dowel and the second dowel is set to 32 mil. Okay, that's fine. And then from the second dowel to the third dowel is 96 or 64. And then from the third or the second to the third is 96. So all of these are preset to be exactly the distance, not close, not about exact. So the next thing is to set these up so that they actually are attached correctly to this particular piece of furniture. So we go to Woodwork Design and I pick Attach and I touch the planes. And everybody gets prompted. Now for reliability of accuracy, okay, for standardization within the group, this really stands out because everybody does it the same way, and everybody's holes should come out the same way. So it's asking you to select the front face of the cabinet, which is here. Select the top face of the cabinet, which is there. And select the top edge of the cabinet, which is there. And you could see that it automatically constrained the work planes to exactly where it had to be. Not close, but exact. And if for some reason you needed it to be longer because this is an 18-inch cabinet and I only have 15-inch worth of work planes, you could again say I want it to go greater than 15 inches and pick OK. And it still maintains the constraint, but you could see that now if we had a depth of a 25-inch or a 30-inch cabinet, the dowel boring would be correct and absolutely accurate. So how do we create those work planes? Because that's step one. We must create boring planes to be used over and over and over again, and that is our next step. The creation of work planes in Inventor is quite simple. Our goal is to standardize the way that our group actually designs and creates data, and then of course link it directly to the manufacturing process. With the usage of this tool, plus some of the other features I'm going to show you, I think we'll be able to accomplish that particular task. What I have on the screen is a 32 mil construction guide for the standardization of building of millwork as well as furniture. 32 mil is a standard within the wood industry, and I would say many of our end users have adopted it. Now, we also have some that have created hybrids of this and others that have gone completely off the map. This will define, of course, the diameter and depth of holes, the spacing of holes for shelf pins, as well as joinery of dowels, knockdown fittings, conformat screws, hinge holes, location of hinge holes. It really covers many, many things. And if we standardize the way we construct or design things, it'll be easier downstream to actually build whatever we do, because it will be pretty much the same over and over again. Locations could be different, designs could be different, but the core of construction that controls the machinery can be very similar. On top of that, if everybody does it the same way, we're standardizing our design department. Okay. So now we want to create our first boring pattern. To do that, it's fairly straightforward. What we'll do is, this is the existing one that I had brought in earlier. I'm just going to go to File, New, and I'm going to create a standard part. I'm going to immediately turn on the XY plane. Turn on the visibility of the XY plane. And then look at it in home view. Now, if you have picked the plane you want to work on, then of course you can do that also, but I want to keep this work plane on. I also want to turn on the Z-axis. So I'll go into Origin and turn on the visibility of the Z-axis. So now what we look at is we have a plane and a center axis that define, of course, the Z direction. And what I'll now do is I'll say finish the sketch. So you can see where we are at this moment, okay? Now, this plane that you're looking at is going to represent the location on the very face of the cabinet, okay? So I'm going to marry that plane to this front face, the long grain face. Now, that's up to me how I want to do it. It's up to me how I want to decide on doing it. So there's no absolute here. It's, again, working with the tool to accomplish the task that you're looking for. So if this is the front of the cabinet, where is the first dowel? Let's say we're doing joinery here, okay? So I'm going to create a plane. I'm going to touch this existing plane, pull on it, and say it's minus 25 millimeters. So the plane from here to here is 25 mil. I'm now going to go back, pick plane again, and this is minus 32 millimeters. So if you're working in inches, then of course do inches. If you work metric, you work metric. But again, because we're working a 32 mil system, this is probably preferable. I'll touch this again, minus 32 millimeters. I'll go ahead and I'll continue. So really what I'm doing here, I'm going to say minus 96 mil. Plane again, minus 96 mil. So within a couple of minutes, you have the ability to create all of these boring patterns either in one file or in multiple files. I'll do one more, minus 96. So if we measure the distance from the first plane to the rear plane, this is 18.622 inches, okay? And that's okay for what we're doing today. Now what we'll also do is I'm going to right click on this and I'm going to say auto resize. On each of these planes, I'll do what is called an auto resize. And an auto resize will allow these planes to adapt well to what they get picked, what gets picked on it. In other words, when we pick what we're attaching it to, these sizes, the size of the planes visually will change or not change, depending upon whether you have auto resize on or off. So again, all I'm doing is I'm going down the list and picking it, okay, and nothing more. Then I'm going to save it. And I'm going to say this is a, let's say it's boring pattern 25 millimeters. Okay, boring pattern 25 mil, and pick save. Now we can also automate this a little bit because I can say parameters here, and I can say this is going to be front. We'll say first dowel. It'll be 25 mil. So I'm going to automate this on top of everything else. Pick done. So now what we have is a set of work planes, and they're exactly what they should be in terms of size. And I also, if you take a look over here, we can start labeling them or numbering them if we want to. So I'm going to go back to the first plane, and I'm going to say this is dowel 1. And the second plane is dowel 2. So now when I move my mouse onto these, you can see it's dowel 1 and dowel 2. Now sometimes you might have a secondary plane, or sometimes you're using joinery, but you're also putting conformat screws in at the same time. So what we can do here is we can create a plane between the two planes that already exist. Now, you really can't tell the difference of one versus the other because they all look the same, but on this plane, I'm going to right-click, and I'm going to flip the normal. And now that looks like a bluish color, and this looks like more of a pinkish color, and that's telling you one side is a positive and one side's a negative. Now, when we do that, you can also notice that when we start looking at these, okay, each of these can also adjust. So we'll say that this, I'm going to rename this one to drill. So now when someone picks it, it'll know that it's a drill rather than a pilot, not a pilot hole or a dowel hole. So we're almost done, but we need to create what are called I-mates, and these are nothing more than half a constraint in our system. Now this first plane here represents the front face of this piece of material, this very front, because the first dowel hole is 25 millimeter back. So I'll go ahead, I'll go into manage, I'll create an I-mate, I'll touch this front edge, I'll say flush, and I'll also give it a prompt. Select front long edge, long face of panel. I can also put a number 1 in front of it if I want, and pick apply. So I now added an iMate constraint. You can see what iMates, again, focused in on straight Inventor. In a later seminar, we'll talk about more about iMates. But for now, I'm going to now touch this axis. And I'll say select top edge of same panel. And that'll be number 2. And apply. And then I'll touch that edge again, and I'll say select top plane of same panel. And we'll say that's number 3. So what I'm doing here is I'm going to set up a standard that'll prompt the user what to do each and every time, so that every user will do it the same way. Consistency and standardization is critical in terms of improving productivity. If I get this file that was done by one of my partners, I'll know exactly how they did it. Thusly, I know exactly how to fix it, change it, edit it, manipulate it. I'll now go ahead and turn off the XY plane, turn off visibility, and the Z axis, turn off visibility, and pick Save. And I'm done. Boring pattern 25 mil. Let's go further with this now. Let's go back and let's use it. I'm going to get rid of the one that's here already. And the one that's here already, as I had shown you when we started working with it, is an I part. And here you could say I want stretchers or nailers. And you can see what it's doing is it's just saying use these planes versus those planes. You can turn things on and off. So you can have one boring pattern being used for many, many different types of conditions. Less than 15 inches and so on. Well, I'm going to dump it. Don't need it. How do we now use what we just did? We go back to Assemble. We pick Place. And let's scroll down and find it, okay? So this is going to be... Let's look for it. Boring pattern 25 mil. I click on it and place it. So this is exactly what we just generated. And the next thing we want to do is attach it. Now you can use constraints like we've done previously. Nothing wrong with doing it that way, but that's the long way. Using woodworking tools that you can download, I will attach, it's called, these boring patterns. And it now prompts the user what to do. Every user is going to be prompted the same way. So it says select the front long face of panel. So if I just touch the front face of this part, like I'm doing here, this first panel is this plane and this plane are now perfectly aligned. Select the top edge there and select the top plane there. So what I've just done here is I've now created work planes that are exactly located correctly. If I measure the distance between here and here, let's look at it in metric, that's 25 mil. If I go back and I measure from here to here, it's 64 mil. I measure from here to here. Again, all these are adjusting or, well, being adjusted based on what I had told the system I wanted. Here to here is 96 mil. So we have accuracy, complete accuracy here if we so desire. Now the other thing we can do here is this, okay? We have the ability to change the fact that this is 25 mil. Sometimes the front plane needs not to be at 25 mil, maybe it's 30 mil for unique situations. Well, in that case, there's nothing stopping you from just going into parameters and changing that one distance. Now, whether we do it through iLogic or we do it any other way, I'm going to say minus 64 millimeters. And you can see that the first plane just moved back and all the others maintained the same relationship based on a 32 mil system. 32 mil. And the goal, of course, is going to be for us to dowel it up on those planes. Now that the boring patterns are complete and adjusted to our particular needs, whether it's one pattern or multiple patterns, the next step is to build the libraries that are necessary for all of the hardware, the joinery, all the unique things that we as woodworkers do that, believe it or not, are somewhat common between jobs. Doweling and joinery are, of course, one of those. So what I'd like to do is show you how quickly we can build a library part and use that library part. I have them already done, but I'm going to show you the technique that we use to accomplish that particular task. To do that, we need to open up a new part. I'm going to create a simple diameter. I'll say dowel diameter equals 8 millimeters. Now, of course, if you're not working in metric and you're working in imperial, whatever the dimensional values are. And then I'll extrude this asymmetrically. Okay, that means from the work plane that I started on, I can move in two directions. So one of those directions will be 0.375 or 3/8 of an inch, or half an inch. Let's make it half an inch, 0.5. And the other one will be 1 inch. Okay, so we have a dowel that's 1.5 inches in length. And I'll pick OK. I'll also, at this point, go into my origin and turn on the XY plane. And you can see that the XY plane is going to determine or define panel A from panel B. That'll be the joint between it, okay? Where a half an inch will go into the side panel and 1 inch will go into the end grain panel, or whatever the dimensional values are that you care to use. Now, let me pick save, and I'm going to call it variable dowel 1. And I now have that part almost created. Let's go ahead and assign some material to it. So whether this is maple or what have you, you assign a material to it. Already done. And I also want to go into Tools, Document Settings, and tell it that it's a purchase part. Bill of material, purchase part, because I want it to segregate from everything else and list it as a part that I'm not going to build. I'm not going to turn dowels. I'm going to buy them. So in the cut list that we have, and any listing we do, we want to make sure we have that available to us, and that's taken care of now. Next step is, this is accurate, it's 1.5 inches, it's 8 millimeters in diameter. The next step would be for us to create now the machining. The exact machining that if we send this out to a CAM tool, it'll understand it, or if we go out to working drawings, it'll understand there's holes in both panels. So what I'm going to do is sketch on the end of this, and I'm going to extrude on top of it to the other side. But the difference here is I'm going to say it's a new solid. That's very important. And pick OK. So there's two pieces on top of each other. Okay. We'll say 2. There. New solid, and pick OK. So you can see there's two solids here. The first solid was the dowel. The second solid was the machining. If the machining is larger than 8 mil, you would have put it in. If the machining goes beyond the dowel for space in the hole, for air and glue, then of course you would have done that also. The major difference in working in this way is that we now have two solids. For the second solid, which is the machining solid, to actually cut and mill the material, I must put a dash in front of the name. So I'm going to just put a dash in front of solid 2, and I know the system will understand the dash and cut into whatever it touches. Sometimes I also change its name so it's easier to see. Not necessary, but some people enjoy doing that. For us to continue, what I'd like to also do here is turn on the Z-axis, and I'm going to turn on the XZ plane, because what we're going to do is create iMates that allow us to actually set this up easily when it's brought into a model and add it quickly to the assembly. So we've done that now. And I'll pick Save. Let's go further and now add. Let's add, of course, the iMates themselves. So we'll go to Manage, iMate. I'm going to touch that work plane, and I'll say 1, select, face, grain for boring, and apply. Okay, I'm going to touch this. Okay, and I'm going to say 0.375, 0.375. Okay, and I'm going to say select, face, grain, offset, 0.75 thick, or whatever information is something that you remember what to do, because everybody will see this and everybody will work from whatever this documentation prompts you for. And then finally, I'm going to pick the center axis, and I'll say select work planes for dowel location. And that'll be number 3. And pick apply, and that's that done. So you can see here under the iMates, here are the 3 iMates. And the order in which I entered them is the order in which it's going to prompt. But you can move these around by just dragging and dropping them if you'd like. I'll turn off the planes and the axis because I don't need them anymore. And we now have the dowel. Last step in the process is I want this to be an I part because I want to be prompted whether it's an 8 mil or a 5 mil dowel. So I'll go ahead and create an I part. This is the D diameter. I'm going to add a row, and I'm going to say this is 5 mil. And I'll also add a description. And the description will be an 8 millimeter dowel 1.5 inch long. Let me just open this up a little bit so that we can see that. Control V, and let's say this is 5 mil. There we go, and pick OK. So right now I'm going to pick Save, and what we have is, of course, this is finished and complete. The last step in the process is to test. So we created a V-dowel, pick Save, and we'll close out of it and come back into our world here. So what I'm going to do is place the V-dowel. The first thing that it's going to do, okay, it's going to prompt me for information, okay. So if I want a 5 mil, you can see it's 5 mil. If I want an 8 mil, it's an 8 mil. Okay, and I can place it, and it's done. Now, for testing, the best way of testing this is to use the tools. You can use iMates or constraints, but the better way is to just use attach. I'll pick attach and I'll touch the dowel, and it's prompting me for the information that I had asked the system to give me before. And now I can either attach either singly, one at a time, or I can attach multiples. So if I say single, it's going to say select the face grain for boring. Okay, so the face grain that I'm going to use for boring is here. So I now touch that. Secondly, select the face grain for offset, which is here. And then thirdly, select the work plane to put the dowel, which is there. Now, let's turn off the shading so you can see where the dowel went. So you can see that it's 1 inch in. It's a ½ inch in, and it's 1 inch in that way. So it accomplished what I was looking for. And let's go to shade it again. And if I now pick sculpt, what it's going to do is it's going to drill the holes. So let's see what that looks like. I'm going to take this right panel and open it. Let's rotate it around, and you can see it drilled a hole exactly where it had to be. Let's check it out. Let's measure. The center point of the hole to this face. Make sure it is in millimeters, and it's 32 mils, so it's dead on and absolutely accurate. So it did what we wanted it to do. Now let's look at it on the other side now. So I'm going to turn off the visibility of it here. I'm going to move it, and the dowel is now cut. And the dowel is exactly on the work plane, as you can see. Now, what happens when you dump the dowel? Okay, let's go ahead and sculpt again. It heals. Okay, so what you just saw here is a way that allows you to be absolutely accurate and standard with everything that you do. Let me turn on the visibility of this, and let's do it one more time, but I'm going to use one of the ones I already had in place. Okay, so this is the method that I normally would use. I would pick place, I would go to my library, I'd go to connectors, and I would go ahead and pick wood pins, and I'd pick one of the wood pin environments that I normally would use. When I do that, similar, 8 mil or 5 mil, but you can also see that I have the length of the dowel and how deep it goes into the side panel. And again, this is all metric, but obviously this could be English if we so desire, okay? Now you'll also notice that I am going to drill a hole longer than the dowel. So this is what I was saying earlier. So if I want to now dowel everything here, not just one corner, here's the process. I pick attach, I touch the dowel, and it asks you for the drilling plane. I'm going to drill on this face. Well, first of all, what I'm going to do is make sure I do multiples. This is single, this is multiple. I'm going to do multiples now, okay? The drilling plane is going to be here, and it's going to be on the opposite side of this board. There. 3/4 inch material, touch here and here. And then the axis or the work planes I want it attached to is 1, 2, 3, 4, 5, and 6. And I pick attach. What this just did is it put in quite a number of dowels all at one time. Make sure I get rid of all of that stuff that I don't need, okay? Okay, so let's see what happened here. I'm going to sculpt and sculpt my work. I'm going to touch this piece and open it. Let's rotate it around, and you can see that this is all complete and done already and accurate. Let's go further with this and turn the visibility of that off, right? And if I want to, I can turn the visibility of the boring pattern off. I don't need that on. And if we move any of these, right? Sorry. You can see that these are all drilled. If we open up this piece, this is complete. Now, let's say that we made an error. Does happen on occasion. Let's do an update. Update our work. Everything goes back together. Let's say we did make an error in our judgment, okay, for what we just did here, okay? So I'm going to turn on the pattern again. Let's turn off that one and turn this guy on. This is 25 mil off the front right now. If I say, no, it's 32 mil off the front, my mistake. If I said that this was 25 mil off the front and pick done and hit return, you can see that all of these holes, all the dowels moved forward, but the holes stayed where they were. If I went ahead and sculpted one more time, then of course, because the dowels move, the holes move. And now that's accurate again. So again, this is just a very fine and easy way to build. And what we just did here with a simple model can be extrapolated into the most complicated type of woodworking you can imagine. If we went to a bill of material, let's just do that and check that out. Bill of material. You'll see that I have 24 wood pins. They're in the system right now also. Let's turn on the left side and the right side of this unit and look at the entire assembly. So in the browser, we'll just right click on them, pick visibility, and we have them turned on. Now that we've created joinery for the center with the boring pattern of what we've defined, maybe on the right hand side I'm going to use biscuits instead, again just as examples. So I'm going to say place, and you can see that we have libraries of all kinds of items, or you can build your own library. And I'm going to go to fixed joints, lamello biscuits, and I'm going to grab one. Now, what's interesting about this, just like when we have the different dowel diameters, we can have the different values of biscuits by their naming conventions that the hardware vendors actually have decided upon. And of course, we can change their values at any time and place it. Okay, so let's say we want to put 1, 2, 3, 4, 5, 6 biscuits in, okay, at any time. Also, if we want to put them down the back and we don't have a boring pattern, or we don't want to build a boring pattern, all we have to do is select work planes, define where they should go, which I'm doing right now. And you can see that we can define work planes so that they will automatically adjust to where they are at this moment, the planes themselves. So again, quite simple. Let's attach this lamello biscuit. And I'm going to do multiples, and it's asking you for the miter plane, okay? Again, naming conventions, what are common to your world? So what I'm going to do is I'm going to move my mouse onto this edge, and then select that face. We've already done it. Now, inside plane. The inside plane I defined as the bottom of the shelves. So that's 1, 2, and 3. And then finally, what center axis, okay, or work plane do you want them attached to? So I'm going to put one there. I'm going to put one here. And if I don't want to use any of these others, I don't have to. I could if I want, or I can put another plane here if I want. And I pick attach. Once that's done, I'll sculpt and sculpt this. Now, once this is done, we can take a look and see what just happened here. I'll get rid of the master, and let's move this. Let's rotate it a little bit. And you can see that those are done, and these are done. It's very, very simple to do. To accomplish this. Now let's turn off the visibility of that, okay? So you can see that if we move these, okay, if we want to move these, we can. And you'll see that they're cut into the sides here. Again, absolutely accurate. Again, going the opposite way is more of the same. There's two more items that I'd like to show that really covers a lot of territory. These are all, again, negative shapes. In an upcoming seminar, we'll talk about positive shapes, and positive and negative shapes, like a mortise and tenon joint, would be a positive and a negative shape at the same time. One of the key areas of interest that many of our woodworkers do get involved with is pocket screws. And pocket screws are kind of unique because they're sometimes not machined. They're put in with other tools. Sometimes we let the shop put them in for us, and we don't call them out on drawings because it's just too much work. But again, because they're simple to do with the tools that we have, then maybe we will start including them. But again, that's your choice. So let's say that there is going to be a top panel put on here, and we want to put pocket screws to attach this top to the sides. Again, I don't think I'd do that, but for example, for what we're doing today, I just want to try to use this example as best I can. So the first thing we're going to do is I'm going to go back and I'm going to say place for my library. Let's go to my woodworking library. Let's go into screws, and I have pocket screws. So for all intents and purposes, simple screw. You could see the lighter tone. That means it's going to cut. That could be invisible. I'm just showing it. And maybe I want to put a series of pocket screws on the left-hand side and the right-hand side. Again, everything that I'm doing here with all the joinery is only a couple of minutes, and it's fully functional. And if I change the model with iLogic, of course, this all changes with it also. So let's go ahead, and I'm going to say attach the screw. And if I'm going to put 12 or 13 screws in, think of all the effort you would have to go through in almost any other system. I'm not going to put one at a time in, I'm going to put multiples in at a time. And it's asking, I spelled this wrong, I see that, face for drilling. Well, this is the face, and I pick that. Drill into what? I'm drilling into this side here, and I'm drilling into the underside of that, as you can see, or I can rotate it around and pick that side there. Next thing it's asking you is to pick the axis. Okay, pick the axis. Okay, obviously the boring pattern is perfect. It's perfect alignment. That's what could focus everything in a cabinet or a piece of millwork. Shelf pin holes, hinge holes, everything lines up. So I'm going to put let's say 1, 2, 3, 4, 5. That's going to be 10 screws when I'm done. And I pick attach and sculpt. Now when we look at this, I purposely had it change colors so you could see that, but you notice that it's actually put the pocket screws right on the dowels. They're dead on. That's the accuracy you're going to get. And if I get rid of one of the dowels, okay, which I can just pick on these and get rid of them, then the holes would be there on its own. But you can see there's a screw right on the dowel. And that's now complete. If we take the center by itself and open that particular file, take a look at it from a view, there is the pocket, there is the hole for the dowel. Again, very accurate both sides. Let's go back to the shading on this, and let's come back out of that. Okay, the last thing I'd like to show today is cam connectors, okay? Mini connectors. So let's place from my library again, connectors, mini connectors. And I'm bringing a mini connector in that has options. If we take a look at this mini connector, we could have dowels, we don't have to have dowels. And many of our library parts, and I've always suggested to all users, have the options of handling certain things. So if I want to exclude both of the dowels, I could, or I can say just keep the right one in, the left one in. Again, completely up to me how I want to handle that. So let's say that I want to put a cam connector connecting the shelves to this side board. Pick attach, touch it, and it's asking you for the connection plate. Okay? The connection plate will be this vertical plate. Where do you want to put the cam? Well, I'm going to put the cam 1, 2, and 3. And then finally, again, the same thing with these planes. Where are they going to locate? Well, I'm going to locate one here, locate one here, and locate one here. And pick attach. And close. So let's take a look at what just happened here. It put 3 cam connectors on each one of these particular boards. And if I sculpt, it's created 3 holes, 6 holes, 7 separate holes that absolutely line up. So let's look and see what that looks like. Let's just move this out of the way. Let's see if we can. Let's just open this up into its own file. Cam connectors there. In fact, on all of them. Those are the holes that got drilled. Let's turn it off here. Okay. As you can see that this is all automatically been done. Each of these, of course, is controllable by itself. Okay, so we're going to move any of these, okay? And that's complete. All of these going into bills of materials should list everything here. This is listing just the left unit because that's the left unit that was the only one open. Let's go back to the top level assembly, do a bomb on that. Let's scroll down to the bottom, and you can see there's 9 mini connectors, 6 lamellos, and 24 wood pins. And 10, of course, pocket screws. If we go out to Excel with this, what Excel will do is it'll create a full listing of everything here and actually create a structure that will place it in a report that you can generate, or it generates on its own. Material summary, and you can see here the purchase units that have been applied. Thank you once again for attending our session this afternoon on woodworking and joinery. If you have any thoughts on other topics that you might like to learn about, please drop us an email or a phone call so that we might be able to implement them in upcoming presentations. Again, my name is Steve Whittam, and I appreciate your attendance this afternoon.